Coming up on This Week in Radio Tech, Jim Tyner is the CEO of Tower Elevator Systems. You talk about a niche industry where you've got to cross your T's and dot your I's. Tower elevators and other industrial elevators, really unusual stuff, and it really applies to broadcast. This is so cool. It's coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics, with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to, we're going to talk about the light bulb at the top of the tower on this episode. I'm Kirk Harnack here in the Telos Alliance studio in Nashville, Tennessee. It's an amazingly beautiful, still kind of winter day, but it's late winter. We're about to hit spring any day now, pretty soon, and it's just a gorgeous day here. I was talking to a friend of mine in Saskatoon, Saskatchewan, Canada, just a little while ago. He said it was something like 28 degrees there, and they had almost 1.5 feet of snow on the ground. And I said, dude, it's 78 degrees in Nashville. My goodness. Well, that's enough for the weather report. We've got Jim Tyner as our guest today. We'll introduce him in just a minute. But first, let's chug on up to Mukwonago, Wisconsin for Chris Tarr. Hey, Chris, good to see you.
Hey there. Good to be seen. We've had just an amazing stretch of beautiful weather here. We were in the almost to 70 for a couple of days there, and now it's going back to normal. And we got some rain in 40s and probably going to get into the 30s again. But I was able to enjoy a couple of days of really nice weather, got some work done, was able to get out in the field to a couple of transmitter sites that normally I wouldn't get to this time of year. So, it's been wonderful. And now back to normal. But here we are. Glad to be here today, and a little bit of time indoors away from the yucky weather.
Sounds like we had good weather for building tall towers, and we got the right guest to talk about that. This is a gentleman who I have known his name for years. I've actually, in a way, roundabout way, done business with him for some years, but I'd never shaken hands with him. And I guess I still don't get to shake hands with him until I see him at the NAB show coming up in April. Please welcome Jim Tyner, the CEO of Tower Elevator Systems. Jim, welcome into This Week in Radio Tech.
Thank you very much, Kirk and Chris. Happy to be here.
Jim, my goodness, we're going to talk about not only towers, but we're going to talk about elevator systems in towers. It's a really niche topic, but I think it's fascinating. But give us the little elevator speech on who Jim Tyner is and why you and your family have been in the tower business for, oh my goodness, over 80 years, maybe?
It's been a long time. I am second generation. My dad is a very young guy starting out and worked down in Texas. Went to work for the power company and learned to climb poles. And somehow from there, he ended up working for a company out of Oklahoma that was building a number of different things, but part of that was AM radio stations, including the towers and the ground systems. So he was one of the early guys that got experience at the time when towers started getting taller and larger. And that was probably 1940 or maybe late 30s that he was helping with the AM constructions around the country, working for John F. Beasley out of Tulsa, I think it is, or Oklahoma City. And at some point, he felt like he knew enough about it, he could start his own business. There was a boom in tower construction. And in 1948, he started his own business. And one other gentleman, an accountant person, came with him to found that company. And I grew up, since that was 1948, I had just been born. So throughout my early years, I was around the tower business. Unfortunately, my father, in an accident, fell 600 feet, got killed. in 1970 or 70. I think it was 70. He was a young man, only 61 years old. I had started my business in 1969, and unfortunately, I was not working with him anymore and wasn't on that job site. But from 1969 on till about 2004, possibly, I worked exclusively on broadcast and primarily tall TV towers. As you know, some of the really tall ones have elevator systems in them, and working around those things, I realized they could be improved. They were not being kept. They weren't keeping up with technological advances, especially in the control systems. And as the boom in tall TV towers kind of ebbed a little bit, there were only 2 or 3 companies building these specialty machines. For various reasons, they no longer supported the existing station owners that had elevators. I decided I had some good ideas, and I applied for a patent. I got a patent, and based on that, I blindly charged forward and started an elevator company from scratch in 2004, I think it was. And we have branched out into heavy industrial machines. This is really cool, and we were awarded the design and installation of the elevator inside the Statue of Liberty, in the actual statue, not in the support structure beneath it. So we did that one, and we really go after these custom jobs. This past summer, we just finished a job for the Jeff Bezos Blue Origin rocket launch site out in West Texas. They needed an 80-foot tall tower for the astronauts to gain access to the ships. So we finished that this last summer. Pretty interesting job. But since I had so much experience with tall TV towers and these elevator systems, we really dove in on trying to take advantage of the technological advances that we could have in the controls to make them safer, more reliable, things like that. And we think we've succeeded pretty well. So we offer upgrades to the control systems, to the overspeed brake systems. We design, manufacture, and install replacement elevator cabs. A lot of those have rusted out. Cables, the entire array of maintenance and inspection services so that station owners can remain compliant with the laws, the codes, and so on, and try to mitigate the liability exposure of owning one of those things.
Wow. This is a lot to take in. And hey, we're going to be looking at a diagram, a crucial diagram, where Jim's going to explain just how some of these elevator systems work and what makes them work, what makes them safe, and what makes them unsafe. So that's coming up. Plus, we have a lot of pictures to share with you. So we got a lot to cover in 1 hour with a real expert on this, Jim Tyner, the CEO of Tower Elevator Systems. I'm Kirk Harnack, and let's hear a real quick word from Nautel, one of our sponsors here on This Week in Radio Tech. Go ahead and roll it there, Suncast.
Speaking of ice falling on things and specifically personal safety, which we'll probably get to in a little bit, I have a rule that I think everybody should follow, or if you're new to cold weather country, pay attention to this. Always wear a hard hat around your towers when they have any ice on them, especially if you have FM days or any sort of antennas on the tower, or even an AM tower, because the ice will fall off and eventually clock you or whoever else is on the ground.
Nautel brings you Transmission Talk Tuesday. It's a roundtable discussion with you and other engineers and Jeff Weldon, and typically a guest or two talking about a technical topic, and you're welcome to join in as well. At the moment, there's not another one scheduled yet, but there will be soon. So check in at nautel.com/webinars and then click on Transmission Talk Tuesday. For weeks, if they don't have one going, a new one, you can go look at one of the older ones in the archive at nautel.com/webinars. Thanks a lot, Nautel, for sponsoring This Week in Radio Tech. All right. Hey, I'm Kirk Harnack. Chris Tarr is along, and Jim Tyner is here. Jim, we got an hour and no more. So let's jump right in. I want to take a look at that diagram, and I know Suncast is going to be really busy here bringing up pictures. But Suncast, if I emailed you that diagram, and it's ready. Okay, good. Jim, can you start us off with this? Most of our audience knows what a tower is, although we don't necessarily know when a tower deserves an elevator. So maybe you can kind of hit that at the same time that you're telling us about how they're put together.
Well, just to answer that last question, the tower guys think that every tall tower should have an elevator and that it deserves it. So other than that, there's economic analysis that a station owner probably undertakes to make a decision if he's going to purchase an elevator and maintain it, be exposed to the liability of having the thing on his property and his work site. So generally over 1,000 feet is kind of the height criteria where they become seriously considered. I think the more broadcasters you have, the more systems that are mounted on a tower, the more likely the economic value becomes a strong consideration for developing an elevator on a tall tower. They are highly prized when there is a burnout or an emergency, and they'll save money every time someone needs to maintain the tower. So
I hadn't thought about it that way. Okay.
Yeah, very very few of the 2,000-foot max height by FAA rule, primarily in the Midwest. Most all of those are going to have elevators. There's a few around, and I promise you, the guys that have to climb 2,000 feet are complaining loudly all the way that climb.
Yeah. Where does a tower owner have more liability? A tall tower without an elevator, or a tall tower with an elevator, or is it just different kinds of liabilities going on?
Well, there's two distinct liability concerns. A tall tower is inherently hazardous, and an owner has to go to great pains to make sure that access to that tower is limited to only those people that are qualified. That's true of any tower, regardless of its height. But on a tall tower where there is an elevator installed, you create additional hazards, additional risk, and liability. So there again, not only does the owner need to pay attention to maintenance of the tower structure, the support structure, but now he's got a mechanism that falls under a whole array of codes and state law about maintenance and so on. So you got an elevator is inherently hazardous on these tall towers. It's completely different in the way it operates and than a commercial building where you get in, push the button, and everything's automatic. So
on that diagram. I'm sorry to interrupt. I want to look at that diagram. I'm sorry. I'm just so curious about that, and I hope I'm not out of order here. If Suncast can pop that diagram back up, does the top deflector sheaves? That's the I would call them pulleys at the top there. On these elevators, are they going to run the entire height of the tower from bottom to top, or do you ever have two elevators? Do you ever have a midpoint where you get off one and get on the other?
I don't know of any that would do that. A standard broadcast tower here in the United States would have a continuous run of that elevator on a 2,000-foot overall height tower to the tip of the lightning rod. The elevator might run to 1850, just below the top cap section of the tower, and those top deflector sheaves will be right up at the top. What you're looking at here, that machine drive is maybe up at 30 feet, possibly.
Yeah,
it varies.
Yeah. So you've got to climb to that level. Yeah, go ahead.
Yeah, there can be ladders, there can be stairways up to gain access to the elevator car. Besides the fact
t-
that, go ahead.
no, tell me, I wasn't clear on that diagram how the counterweight is attached. Can you tell me
Right.
about how you size that counterweight and how big is the cab of this thing?
Right. Go ahead and put that drawing back up if you could, please, Suncast. So if you look, it's not titled counterweight. It's titled tension weight.
Oh,
And that's a distinction between this machine and a normal or standard commercial elevator that does have a counterweight. So if you could zoom out on that sketch, it would be good.
Oh, I see. Okay, so that weight doesn't
Yeah.
go up and down the tower opposite the cab.
No.
It just
No.
keeps tension on the whole long cable. Okay.
Right. It's hanging in the belly of the cable, and its purpose is to maintain tension because the machine is a gearbox and a motor, but the sheave is a grooved sheave that creates traction or friction on the cable. This machine is what is called a traction drive. Now, in a commercial building, that machine would be at the top instead of the deflector sheaves being at the top. And you would have a counterweight hanging on one end of the cable on one side and the cab hanging on the other. So, and the cab and the counterweight both exert tension onto the drive sheaves in a commercial traction machine, creating the friction that is needed on the drive sheave. So here it's a closed loop system. Hoist cables, and there are two hoist cables, almost always 5/8 inch in diameter, galvanized wire rope. There's two of those attached to the top of the car, and they go up the tower over the deflector sheaves to reroute the cable out of the hoist way and bring it down the side of the tower and around some other deflector sheaves and up over the traction drive sheave that's attached to the gearbox, and then down, as you can see, around a sheave that's free hanging. The tension weights are free hanging. They're just on a guide rail rack. So we have constant tension on that hoist rope so that we maintain control at the drive motor. And there is a brake. It's a brake motor. And there's also another independent brake on that drive so that if it's maintained properly, you hit the stop button in the car, you stop. Up on the car, you asked the size of the cab. The car, it's titled here. Generally, two people. You can squeeze three in there. You're limited to what's called the rated load. It can be generally from 750 pounds rated load. You'll see some up to 1,000 pounds. These machines are classified by the code as special purpose personnel. They are not intended to be freight elevators, although it's quite common down through a long history of tower work being done for these machines to have been used to carry freight, transmission line pieces, things like that up and down a tower, when actually they are by code regulated to carry in the people and their small tools and so on, supplies. So if for some reason the motor drive system did not stop a car and it started traveling downward beyond a set speed, there's a governor on top of the car, and there's a big rubber wheel that's attached closely to the guide rail so that it is being turned by the car travel. And there's a set of flyweights. It works off centrifugal. It's a centrifugally actuated governor. And that's one of the things we do during our maintenance inspections and so on. We'll use a tachometer and spin that to make certain that it's set properly. And if it exceeds the set amount, the little flyweights through centrifugal force get extended out and trip the overspeed brake. There's a mechanism that connects from the governor down to the bottom of the car. And this overspeed brake has some very powerful springs on it and on either side, so that it comes in contact with the rail on either side of the car are a couple of dogs. They're grooved, heavy, wedge-type devices that the spring causes to go out and engage the rail, and then they knuckle into place. So that's your overspeed safety brake. The car buffer is just springs that you might imagine down at the tower base. It's not intended to capture a falling car, but it will arrest the car if for some reason the bottom over travel limit switch did not cut the system off.
Wow.
Give you an
Okay.
give you an idea of scale. Like it's a 3-person cab, maybe 2 or 3, and those deflector sheaves might be 20 inches in diameter, something like that.
Okay. Well, that makes sense. Sounds about right. Is Chris Starr still on with us? I hadn't seen him on a triple shot lately.
Yeah, I'm here.
Oh yeah, there he is. Good. Hey, Chris, I've never gotten to ride an elevator. I've climbed plenty of towers, shorter towers, certainly. Have you ever ridden on a tower elevator?
I have in Milwaukee,
Really?
as a matter of fact. Yeah. It's the only time you're ever going to see me on a tower, by the way, because I'm not going to climb.
Right.
But it's interesting with tower, with the maintenance of these elevators, because they really do need to be maintained. I don't know how many times at one of our towers in Milwaukee where the guys go to climb and the elevator doesn't work, or it's being serviced and it's been out of commission for a long time. And, it is one of those things, unfortunately, maintenance wise, it tends to get overlooked sometimes. So, having those elevators in working order is really, really important, because nobody, even 1,000 feet, people don't want to climb. So
absolutely,
you get these elevators, and you got to make sure they work, and there's a whole safety routine before they get on them to make sure that they're safe to travel on, and those sorts of things. So most of, or all of our towers that I have now are all fairly short and don't need elevators, although they still complain about climbing a 500-foot tower, so that's going to happen. But I unfortunately, or fortunately, I guess, I don't have any towers tall enough for elevators, but I have been on them. They're a lot of fun. I really it's an interesting experience to do it. Everybody should do it at least once.
Hey, we are talking to Jim Tyner. He's the CEO of Tower Elevator Systems. It's This Week in Radio Tech, and I'm Kirk Harnack, and Chris Starr is along here. We got a lot more to go, a lot of pictures, and a lot more explaining that Jim Tyner is going to give us. This is just fascinating stuff. And I can't, when we come back from this quick break, I got to find out from Jim about, these elevators are out in the elements, rain, snow, sleet, cold, hot, everything. They're out there. So unlike, the elevator I rode today with my wife to the doctor's office, that's in a nice temperature controlled environment. So we'll be talking to Jim about that and look at some great pictures coming up too. This Week in Radio Tech is brought to you in part by Broadcast Bionics and the virtual rack system. We've just been doing some work here at Telos Alliance, putting on a new webinar about the Axia Altus. And one of the ways that you can deploy virtualized broadcast systems is in Broadcast Bionics Virtual Rack. It makes this easy because I got to tell you, Docker containers are not for the faint of heart. They are not easy. They're not simple. Now, if you do this all day, every day, fine. You know the techniques, the words, about Mac VLANs. But if you don't know about those things, Broadcast Bionics has made it easy. What they do is when you buy the virtual rack, you get a server. They have 2 different sizes to choose from, and each of them will host a different number of what they call application units. So maybe an audio console takes up, 1 application unit, and maybe a phone system takes up 2. And different products take up different things. And by the way, this isn't only Telos Alliance. You have products available from Sound 4 and from 2WCOM. So when you get your virtual rack, you browse into it, and it's like an app store. You pick the broadcast appliances that you want to instantiate in the virtual rack. You click on them, they install. You give it an internet connection, of course, but they install right there within a couple of minutes. I've watched this myself. You can go to an NAB show or get a demo yourself of how this works. There's some videos online with Dan McQuillan showing how this works. They install that takes care of all the networking internally for you. So all that hard work is done under the hood. And then you still need to license that application with its respective manufacturer, whether it's Telos Alliance or Sound4 or 2WCOM. You would license it. Some apps, have some limited working that they do without licensing, so you can try them out. And so there you go. That's what Virtual Rack is. It runs these things virtually. So audio consoles, phone systems, audio processors, and then even banks of codecs, for example, from 2WCOM will work this way. There's also the possibility for failover, so you can get two of the Virtual Rack systems and have a hot standby, a hot failover right there for you. The folks at Broadcast Bionics will absolutely help you through this. You do it once, you probably don't need any more help to install more of them. And it all works on your network with audio over IP. You need to check this out. From Broadcast Bionics, there are several different options for installing virtualized broadcast equipment, and this is one of them, and it's probably the easiest. So check this out from Broadcast Bionics. Really appreciate Broadcast Bionics being a sponsor of This Week in Radio Tech. They are heavily involved in the broadcast equipment world, and they can make you and me look great as station engineers in saving stations money and offering a lot more flexibility. All right, it's This Week in Radio Tech. Chris Tarr is along with us, and Jim Tyner is our guest. Jim, I mentioned before the break the notion that these elevator systems are out in the elements all the time. What does that do to an elevator to be out in the weather?
Towers are out in the elements. They're subject to high winds, icing. It's really tough. Corrosive atmospheres, so on. So all of those same concerns apply to elevators too, although in some areas we pick up maybe a few different ones, primarily because of the electronics. As you guys would know, electronics outdoors certainly is a challenge. Corrosive atmosphere, temperature changes, especially very hot days can be hard on those electronics. The cables fall under very strict dimensional code requirements, and hanging up all the way up a very tall tower, the small diameter wires that make up a cable are just not that resistant to rusting. So even though they're galvanized to start with, they don't last as long as a tower structural member might. So it's more challenging to combat rusting and maintain a safe elevator system, more so than a tower. And I think that may be one of the reasons in some cases they get neglected, because they need to be maintained on a more frequent scheduling than a tower would be.
Let's take a look at some of these pictures. So, like I said, we got a lot of pictures and not a lot of time. So, hopefully, Jim will pick some of the ones that you want to talk about. What are we looking at here? What's your description?
That's an interesting machine. That, believe it or not, that's an elevator cab on the below all of the control panels there, and that is inside the Statue of Liberty. That's the early stage of assembling the machine that we put inside the statue.
Wow!
And you can see there the enclosures are stainless steel. Everything very robust. If you're familiar with a PLC, and I imagine most of you are, you'll know that there is such a thing called a safety PLC, which encompasses a much higher level of safety than a standard PLC. And that's all we use in any of our machines. From day one, we have only used safety PLCs in our control systems.
Okay, let's move on. Next picture.
That's an early picture. Yeah. That's the panel that's in that machine.
Wow. So that's in the Statue of Liberty now?
It is. It is.
Wow. Okay. That is
I'm
so
sure that's
cool. All
right.
right.
I'm pretty
What's
certain
next?
that's right. And
Looks like
actually, the
more
white,
construction. Yeah.
yeah, that's basically the same cab again in some stage of assembly. And the white is a vinyl coating over the stainless steel exterior of that cab to keep it from getting scratched or damaged. That's inside our shop in Round Rock, just outside Austin. We've got
Okay.
two nice sized buildings there where we do manufacturing, and we have an 80-foot test tower that all machines before they get shipped go through a full array of testing uh, for overspeed, for rated load capacity, for emergency braking systems. And I got to go up in there. That was pretty cool. It was an
I
interesting
would guess
job.
so.
Yeah, that's my foot.
Oh wow.
So I'll tell you an interesting story. Like on the right hand side, you see that jagged rail. This is a
Yeah.
rack and pinion drive machine. So there are no cables. The cab is fitted with the motor on top of it, and it has a gearbox with a shaft and a pinion gear cut to fit that rack, those teeth on top, and that's what drives it. And the guide wheels hold the thing in place. So we power it with a hanging cable below the car, uh, and the motor's on the car, and it's climbing up and down using that rack that you see right there. So during the installation, uh, we had to exactly follow the blueprints. This was strenuously explained to us by the National Park Department that oversees the statue. And we came to a place where we needed to drill a different hole, and it basically is like getting an act of Congress. There's a committee in the United States that had to go through, and then one in Paris to drill one extra hole. It was very interesting. You couldn't do anything in there unless it was written down and a plan in place. Very interesting.
Wow. Okay. By the way, is this an elevator for personnel or for any tourists, disabilities?
It's for security and for rescue. It's not for the general public. They still have to climb.
Gotcha.
I'm not sure if there are exceptions to that or not, but my understanding was I have not been back since we finished the install. But
who's this 11-year-old boy and a man there?
This is pretty funny. I think maybe, I'm not sure when, I was poking around the internet, and I think it's newspapers.com or one of those like that. And I just started researching. I wanted to find some pictures of my dad and his early work. And I did find some. RCA, the predecessor to dielectric in the antenna business, had sponsored a group of what they felt were the likely companies to know how to handle construction of big batwing antennas in particular and how to dress them. You had to bend a lot of the feed lines on a batwing antenna, if anybody's familiar with that, are done manually in the field because the antenna is too long to be shipped in one piece. So RCA assembles a big meeting with all these guys there, and darn if I didn't find that newspaper article. And there were maybe 5 different contractors that went on to be the pioneers in building tall towers and installing these very heavy broadcast TV antennas, especially the low band 2 and 3, and even all the way up to channel 6. They're pretty heavy. So I found that article of my dad, but then I just kept looking, and this one popped up. There was a newspaper article that was about me. It had 2 pictures and an article like's on the other picture. But I'm 11 years old, and I'm riding on this headache ball, it's called, a lead-filled weight. And I'm wearing my gloves because I really did work. I had a tool belt and the whole thing at 11 years old. It's crazy. I had worked a lot of summers before that, though, in the very beginning, learning how to uncrate a box full of bolts and they were all shipped without the nuts or washers on them, and we needed them assembled for the crew, and I learned how to do that. And then
Sure.
later on, I got promoted to working on the electrical systems on the ground, where we'd assemble a bunch of conduit and pull the wire in it. And I just could not wait to get up on the towers. So little by little, my dad let me go up on these towers at a very early age. I don't know what he was thinking. It served me well. He taught me how to work. That's what he gave me.
Wow. Wow. All right. What are we looking at here?
This is a picture. That's me right there. I don't look anything like that anymore, but I'm free climbing. This is way before OSHA imposed a lot of regulations on climbing, and that's how we learned to climb. I'm not the only one doing that. The industry was built with free climbers, and that's a great big gin pole. I'm working on an antenna. I had 3 men in my crew and an operator and a ground man, and we put that big thing up there and put it together and take down a 10-ton antenna. It's pretty amazing. We climb all over these things. Nobody ever got hurt, hardly. Occasionally, there would be a fatality, but everybody worked pretty smart, and they were quite skilled. But looking back on it, it's
thinking about the fatalities that you've known about. Do you feel that fatalities could have been avoided, reduced with the current OSHA, climbing harness and safety requirements?
It's hard to say, Kirk. We've all seen the pictures of the guys having lunch, sitting on an I-beam up in New York or Chicago, building a skyscraper.
Sure.
Those things that's the way steel erection was done. This country was built on the backs of these guys that learned their trade. They were hard workers. There was a camaraderie between them. They helped each other learn how to work safe. What changed in the tower industry is we went from onesie, twosie, big tall towers for a TV station to literally hundreds and thousands of cell towers being constructed. The man force needed for that was just something that had never been imagined. There was no mechanism to manage the hiring, the training, the organization of this workforce. And it's a good thing OSHA has regulations, and it's an excellent thing that the cell providers and the tower consolidators demand safety. In the early build out of the cell systems, there were a lot of accidents, and it's not surprising to me because they had a bunch of guys that had not been tutored, that were just hired and put to work entirely too quickly, and that just doesn't work. That's like trying to teach somebody to fly an airplane over this weekend. So the distinction there is dramatic. Whether or not the OSHA regulations would have helped in the early days of the bridges and dams and towers and buildings, I don't know. The mentality was different. The personalities were different, and by and large, the statistics show the fatality statistics were fewer accidents, but you can't really compare them because it's two different animals. Like I say, there were so many new guys working on cell towers.
And what you say about the plethora of cell towers, explosion, and I think even 60 Minutes and other news organizations did stories about the push to get them up and the bonuses paid or not paid, if they weren't finished on time, and the lack of training and really qualified help. So I'm sure all that played into the
Let me just say
regulations.
one other thing about the early days of all of these hardworking guys building bridges and dams and buildings and so on and towers. They were not dumb, and they weren't careless. And it's not that they didn't care about safety. And when something like netting under the Golden Gate Bridge was developed, Mr. Bethlehem, it was embraced, and it did save some lives on that job. So it's not like they were against it. It's just there really was no mechanism for them to take advantage of greater safety. So, but when it became available, it's embraced today, and iron workers today are all wearing harnesses, hard hats, lanyards, all of the things that you would expect. So.
We are talking to Jim Tyner, and let's hit a couple more pictures before we take our next break. Chris Tarr, you're welcome to jump in here if you want to have a question. Jim, what are we looking at here at this truck?
That gives you an idea of the scale of equipment required to construct a 2,000-foot tall broadcast tower. That's one of my trucks. And just by the way, I'm not in the tower construction or service business anymore. I was at one time. I founded my tower business in 1969, and I operated it continuously until about 2002 or 4, somewhere in there. And at one time, we had offices in Cedar Hill, Atlanta, Miami, Des Moines, Sioux Falls. We had a lot of guys working, took care of a lot of stations. This is KMOS, a TV up in Missouri, TV station up in Missouri, 2,000 footer we built. You can see that the tower sections are assembled on the ground. That particular tower section is 10 foot on a face, triangular, 30 feet long, and we've already placed the conduits inside of it, the ladders in there, and a piece of 6 1/8 inch rigid transmission line is in there, and it's in the process of being hoisted. You can see some other sections in the background where they are fully assembled, and there it goes up the tower, and the red crane boom looking device hanging on the side of the tower is what's known as a gin pole. And it extends, it's clamped on the side of the existing tower, whatever height you're at, and a portion of it extends beyond the height of the tower so that you can set this section. That is probably the section we took a picture of earlier, and if you look closely at the flange, just in the right side of the picture, you can see that they're not connected yet. Actually, that tower section is not quite swung around and in place to be connected. So we bring it up, then we swing it around, we lower it down and connect the flange bolts and the diagonal members, and then we move our crane boom or gin pole up 30 feet and fasten it down and bring up another section. When you get up to a certain height, you need to put guy wires on the tower to stabilize it. So we bring those up almost always one at a time and connect them. And then everybody goes to the ground and we pull the guy wires out to tension and make sure the tower is standing plumb. Repeat the process. This particular tower had 9 guy levels. We went through that process a number of times. These sections are solid members. There's no tubular structural members. Those are solid steel legs. I think those sections weighed maybe 8 tons, maybe 16,000 pounds, in that range.
Oh, wow. Wow. That stuff, that just boggles the mind. That's amazing. We're talking to Jim Tyner. Jim runs this company that makes tower elevators now, and we're going to talk more about the tower elevators as we move along. We already saw the elevator that went into the Statue of Liberty. I had no idea. That's pretty amazing. And Chris Tarr is with us as well. In fact, Chris, you've ridden on a tower elevator. I never have. In fact, years ago, I would free climb towers with very little other than a ski rope to hold me to the tower. Not the safest thing in the world. And now I've only climbed a little bit with all the safety gear, not the proper training, but all the safety gear and the hard hat and all that. And it just wears me out. Oh, all that safety gear is just, man.
Like, the one thing too about the people who used to free climb and the guys who, basically built the country, they weren't dumb, and they had skills and they were confident in their skills, and they had a very high respect for the dangers that were there. And I think that's what kept them safe. It's just like when you're working on a transmitter, I always tell people, I'm not afraid of electricity. I just have a very healthy respect for it.
Yeah. Yeah. Speaking of healthy respect, we've got a healthy respect for one of my favorite sponsors here, and well, I mean they're all favorites, but Angry Audio. I was just passed by the office today at Angry Audio. My wife and I were in Franklin, Tennessee, and I waved to Catfish as I drove by. Chris Tarr, you're here to tell us about some Angry Audio product, and there are so many of them, so many worthwhile ones. But you've got a few favorites. What do you want to tell us about today?
Well, today I'm going to talk about the smooth mic processor, and the reason I'm talking about that is I'm putting together. I kind of hinted on Facebook, and there'll be more coming. That I'm putting the headphones back on and getting back on the air on one of our stations, and I'll be on the air once again every day, doing my thing. And part of that is my home studio. And as you see here, I need some new foam. I've got an SM7 microphone into my Rodecaster here, and I'm going to need some mic processing. So I literally, just before the show started, got my email out to Gary at Broadcasters General Store saying, hey, I need to get one of these chameleons. And the reason I want to go with the smooth is, the audio processors that come out of the minds and shops of Cornelius Gold and our friend Catfish Mike Dosh, they are amazing. And I had a demo of this smooth mic processor, and it is truly amazing. It sounds fantastic. And one of the reasons it sounds fantastic, it is that it's designed for the microphone that it's going to connect to. There's the smooth for the SM7 and the upcoming Rebel for the RE20, and they are designed out of the box to sound good with those particular microphones. Now, of course, they're not just, out of the box and don't do anything. They do have some controls there. They have things like the room size, which is, as you can hear my gate going in and out. This is not just any noise gate. This is actually can shape the room and make your room sound really large or small. And it's a really interesting effect. And it's a new take on a noise gate. And of course, you've got brightness controls, the kinds of things you'd like to kind of sweeten things up and make you sound big. That's, you can see there with the gain reduction and room activity LEDs. They have built-in power supplies. The audio, Angry Audio and Catfish, they are known for their clean, pristine audio. And of course, every component in there is meant to make your audio sound clean. And then, of course, you've got all of the brains that Cornelius Gold came up with to make it sound fantastic. It's really, there's not a ton of knobs. It's not one of those mic processors where you can very easily just go crazy and make things sound really, really bad. You can't make this sound bad. You can make it sound phenomenal, or you can make it sound great, but you can't make it sound bad. It is designed for the SM7 microphone. It's going to make you sound great. Get it today. Find it at your favorite broadcast house where you buy your components. You can talk to Angry Audio directly. It's one of many problem solvers that Angry Audio has come up with, their gadgets and their gizmos. They are fantastic. Check out everything they've got online at angryaudio.com. Problems disappear when you get angry. Angry Audio.
I like that. You don't have to go crazy trying to adjust your mic processor. You know why? Because Cornelius Gould has already done that for you.
He has gone crazy to make you sound good.
Hey, thanks a lot, Angry Audio. And also thanks to Max Connect Group. Max Connect they've had this great idea to build a USB connected sound card that is specifically meant for something that the industry has needed. And that is for, the software audio processing, and that's become pretty popular. The company I work for, Telos Alliance, has the Omnia SST. We're about to have another one as well. And then there's Stereo Tool and Breakaway that are all on the market. Unlike other sound cards, the U192 from Max Connect is purpose-built for software audio processing. Other sound cards may or may not be able to deliver MPX signals properly. It can be trial and error to find a card that works, and even then it may require an amplifier after the output to get the signal level up to where it needs to be for your FM exciter. The U192 allows input and output on the same card, which no other USB card can offer. And Stereo Tool, one of the processors, it and others are world-class broadcast processing suites that deserve a real broadcast audio interface. And that's what the U192 does. So whether you're using Omni SST or Stereo Tool or Breakaway, any kind of of software that's got that stereo generator built into it and needs a 192 kilohertz sampled output to give you the analog MPX signal. Well, this is it, the U192. And interestingly, this was commissioned by Max Connect Group because Josh Bone, genius that he is, knew that, hey, I can't design this thing. Who could? And of course, he tapped Angry Audio. Mike Dosh at Angry Audio helped design this U192, and so it's really good. But it's not not an Angry Audio product. It's Max Connect, and they will also give you advice and support on it. So check it out at maxconnect.com, MAXXKONNECT for the U192 MPX USB sound card. Thanks a lot, Max Connect, for sponsoring This Week in Radio Tech. I'm Kirk Harnack along with Chris Tarr. We don't have a lot of time left, but we're here with Jim Tyner. And Jim, let's see if we can slide through some more pictures, and then you can tell us what is going on. I love looking at these pictures, things that I don't often get to see. So, Suncast, you want to see what looks good to you? Okay. Oh, I think I know what that is since I saw the diagram.
Yeah.
What is that, Jim?
And this particular one, rather than having the drive up in the base section of the tower, is down on the ground. So it just requires maybe one more set of deflector sheaves. So this is something we manufacture in our shop, including the controls behind that stainless enclosure. And if you look over by the blue machine, you'll see that black drive sheave on the other side of the gearbox. And there, if you look closely, you can see the two galvanized cables. So the two drive sheaves, the friction traction sheaves, run parallel about 6 inches apart, and you can see them just to the right of the blue gearbox. That's looking at the end of there's a big pillow block out there on the end. And here, and there's a look at an elevator car up a ways on a tower, and it's got an expanding gate door or gate on it, rather than a solid door like you would find on a commercial building. So we write the software and we build the boxes and all this kind of stuff, and they're UL classified stuff, inspected. Here's my guys either take.
I'm sorry, Jim. When you write the software, you've mentioned that a couple times on these that run on these PLCs. What are some of the key functions that you need to make sure happen, and then what does the software need to make sure doesn't happen?
That's a little bit out of my area of expertise. I hire guys that do that, but we need it to start and stop and communicate, and just an array of the operational functions have to be written in, and they've got to be tested exhaustively to make sure that the code doesn't have any glitches in it. So it's all of the things you would imagine for a control system.
What does the software or something else keep the motor from going really fast? Like, let's say you're going to go, 1,000 feet up. I'm sure there's a speed at which it's supposed to go. Is the motor kind of self-regulating by the way it's built, or does the software tell it what to do?
We use VFD, variable frequency drives, that allow us to program in a ramp start and a ramp stop. We use encoders. We use encoders that measure the elevation of the car, and we have what's called an HMI, which is a little screen, a visual depiction that'll tell you the elevation of the cab on the tower, and we can program in. This is kind of interesting. You've got all of the mechanical hazards, the climbing hazards, all those things, but on broadcast towers you have RF hazards and a lot of rules and regulations about that. So it's possible for us to program these elevators to not exceed a certain height until you type in a code or swipe a card. And we also log all of the operations. We know who operated it because they had to code in all of these things. So that's what I meant earlier by bringing it up to a more current technology and taking advantage of that technology to bring a safer work environment for the people.
I was trying to think. Yeah, back to that picture. I was trying to think of something to say about. So, what code would a base jumper put into the elevator to get up to the top?
Yeah, right. Exactly. That's under.
911.
That's under. That's under C. You
911.
go to section C for crazy.
Yeah,
There's
that's
guy
right.
wires, man. You get
Yeah,
tangled
right.
in the guy
Yeah,
wires.
I know.
That
All right,
picture that was on the screen a moment ago
yeah,
was
yeah.
one of my crews actually replacing a car on an
Oh,
elevator, an existing system. So we pull that out of there very carefully. Uh, we do not remove any structural members, so it can be a lot of chain fall work, inching it up and over and out to get it out of there. The reason we have to do that is twofold. One, these cars uh, get rusty and they just kind of wear out. But the governor and the overspeed brake uh, are both certified, and they have a PE seal on them. The ones we manufacture that we test on our tower at our shop, our 80-foot test tower, and we don't have a way to retrofit those two key elements onto an existing machine. So if a system will not pass inspection and gets locked out, which frequently happens, uh, the only way we can fix it is to replace the entirety of the cab system that includes the governor to trip the overspeed brake. So that's what's going on here.
wow. Okay. Oh yeah.
I
There's
don't know if I mentioned about this past summer we did the job for the Jeff Bezos Blue Origin
yeah,
rocket
yeah. You,
launch
you said
site.
that, and I guess we don't want the astronauts climbing the stairs, do we? They're kind
Uh,
of loaded up with
well,
stuff, right?
and it wasn't just that. We built a machine that would carry a stretcher, pretty good sized machine. In fact, on the
Mm.
right hand panel of this image, we're lowering the cab down into our tower, and that's an 80. It happens to be an 80-foot tower that we designed and manufactured and installed, and that's our elevator being dropped down into it. Uh, in the center panel of the picture, to the left of the rocket ship, you may recognize a stair tower. You see the main large tower in the center. On its left side, you
Mm.
can see stairways. That's back and forth, a stair tower that was there. And now we've installed the one that's in the right hand panel next to that center tower so that the guys can get access to the upper platform level to gain access to the ship.
Hmm. Wow.
Pretty interesting. And there it is. And that's standing on the main tower that we were just looking at. That's a stair
Yeah.
tower off to the left. You can see it going down. And then there's a little connecting bridge going into our elevator cab right there. And our 80-foot tower there, we are inside. There's our control panel. And the operator has an HMI, a little operating screen. There's placards off to the right, operating instructions. Uh, if you know the codes, you can tap on that screen and do diagnostics and clear faults and all kinds of stuff. We got really cool software.
Nice. Nice. All right. What's next?
That's a
Oh
nice
my God.
job we did. Uh,
Hmm.
that's the longest stay cable bridge across the Mississippi, north of Baton Rouge, and in the distance you see the two vertical uprights. They're a little over 500 feet tall each, and the near one is the same thing. So we put elevators in all four of those, two in the far and two and four machines total, 500 foot tall, back maybe 10 years ago. It was a very interesting job too. And there's a picture in your group of me standing on top of one of those with a yellow vest on that maybe Suncast can locate. There you go.
Oh,
give
look at
you
that.
an
Good
idea
job,
of the
Suncast.
scale of those things. And we also have a
Wow.
picture looking up to a guy hanging on a riding mechanism inside of one of those towers. They're very large. I think they might be 20 feet in square or something like that.
Yeah. Yeah. All right. What's next?
I thought that was kind of a cool picture. Here
That
we are.
is.
I got a couple of guys. We're building an elevator up the side of a smokestack, 500-foot smokestack, and it's self-bills. That's an aluminum pipe gin pole. There they go. You can see the gin pole sticking up, So in this case, we are installing the rail. We're drilling into that concrete and attaching there. They have a rail section that's hanging on a load line. They have a little winch up there with a hand pendant, and they will stack a section of rail, attach it to the bracket that they've already installed on the side of the smokestack there. You can see above the white hard hat. And then they can move the car up and stack another one. And then they go down and get another 2 or 3 to hang on the car to bring up and install. So it's you can self-build using this procedure with the yellow frame and our aluminum gin pole. Pretty cool job.
Sure. Nice. All right.
There again, those are rack and pinion. They're not cable hoisted machines. The motor is actually on the car, and it has a trailing cable, a cable that hangs down below it to power it. They're 483 phase. That's looking inside of one of our boxes. Shows you the kind of electronics we build.
Wow.
That one is kind of interesting. If you go back to that picture, if you look on the right, you'll see a microphone. I mean, a speaker.
Speaker, sure.
So we actually we typed a bunch of instructions in Microsoft Word, and then we converted them text to voice and put them on a SIM card. And you could actually push a button on that particular machine and get operating instructions, emergency instructions, site-specific instructions, all kinds of cool stuff. So it's a talking elevator.
Now, if you do any talking elevators up north, Chris Tarr is a disc jockey now. He told us earlier in the show, and he can do the whole Wisconsin accent, and he can add a few "don't you knows" on there. And
oh, coming around you there. Oh, look out there. Okay.
That's funny.
Okay, we're going to go up now. Okay. Yeah. Okay, we're going to go up now. Okay, hang on. Oh, hang on there. Tell your parents I says hi.
Right.
Oh gosh. All right. We got time for a couple more pictures. Let's get a few more descriptions. What's this?
Now that one's a broadcast tower. That's the cable hoisted machine that we were talking about earlier. And that's inside a very tall broadcast tower. That's what you'd see. An up button, a down button, and there's the rubber wheel that turns the fly weights I was telling you about, centrifugal force. Mm-hmm. That wheel travels on that round guide rail as the elevator car moves. And if it were to exceed a set speed, it would trip the governor. The governor would force the overspeed brake to engage.
And that overspeed brake, is that a purely mechanical sort of thing that doesn't require power to operate?
I probably have a picture of it in here. It's cam-like devices that have serrated teeth on them that are it's spring-loaded, and if it gets tripped, a very heavy spring forces those dogs up against the teeth, up against the rail, and then they knuckle in. That's a rack and pinion. The other technology, like was in the Statue of Liberty and Bezos' job. And there's your dogs right there. On the right hand, the gold-plated, the anodized, I think it is. Or anyway, you can see the serrated teeth. That's on our test tower. That's why it's a black iron pipe. We're doing testing for certification. We dropped it 100 times, video and numbers and all kinds of stuff. So. And this is the reason I was saying earlier we could not retrofit this thing to an older machine. It's all part of a system.
Yeah.
And those are stainless steel guide wheels down below there.
Impressive.
That's the Statue of Liberty on our test tower behind our shop.
Okay. All right.
That you were looking at earlier on the floor of the shop floor. Mm-hmm.
Yeah.
So I think that one had dual motors, dual drives. That's why there's so much above the cab. That's me sitting on a little hoisting machine while we're on that bridge that we looked at earlier. That's a man-rated yellow. The yellow device is a man-rated hoisting winch, hydraulic controls, radio communications, lots of safety going on. This is a tower out at the San Francisco International Airport. If you look right in the center, right down at the bottom, you'll see an elevator cab. Right in the middle of the face, down in the white section. And then if you follow that upward, you'll see the rail. So the guys that maintain that radar convinced the FAA to spend the money, and they hired us to design and put an elevator on there maybe 15 years ago. We go back and maintain it. We have a service contract with that. And we work all over the country, and I have a couple of machines in Hawaii. I send a crew there once a month to Oahu for the Corps of Engineers, a big machine underground we did.
Wow.
That's on the
Wow.
industrial side.
This is so fascinating, and I tell you, we've got to take our last quick break. Jim, what our tradition is, we after our last break, we look for a tip of the week from our guests. So if you can come up with some words of wisdom or something just to wow us that maybe we wouldn't know that you would know, that would be really cool. Our show This Week in Radio Tech is brought to you in part by Broadcasters General Store and the indispensable tool for recording and editing phone calls and other audio quickly and easily in your radio station. It's Vox Pro. We'll be right back.
Hey, what's happening? St. John here, coming to you from Command Central, and wanted to tell you about the absolute best partner you can have in radio. I'm talking about, boom, Wheatstone's Vox Pro. Now, a lot of folks have used previous versions of Vox Pro, all awesome, but I want to tell you about some of my favorite new features in 7. And for folks who've never used Vox Pro before, I'm about to tell you why it's an absolute game changer and essential for really fast-paced multi-element radio. Lots of different audio software out there. Why Vox Pro? Because, it was designed for radio. It's the only software designed to do what we needed to do, which is record, edit, playback in real time. When I say lightning fast, I'm going to show you how fast you can edit stuff up in Vox Pro right now. Literally 3 clicks on the controller, mark left, mark right, everything that gets marked, you hit delete, it goes away. It's literally that fast. So we're going to take this part right here.
Caller 9.
Boom. From caller 9 to him saying, I'm ready.
5. Ready for that secret sound.
Boom. All of that stuff, hit delete, it goes away. Here's your edit.
You are tackling secret sound, caller 9.
I'm ready, St. John.
So one of the best features of version 7, this is awesome. It's effects macros, and you can literally put a chain of effects together so that instead of having to normalize a phone bit and then use noise reduction on it and EQ it and all that, you can literally build a chain. One button, this one's called call right here. I just click that. All of those processes happen instantaneously. Literally saves 80% of your editing and cleanup time. Final thing that I love about Vox Pro, and there's so much more to get into, but one of my favorite things, you can load it on a laptop. I've literally done my show from a hotel room in Armenia to the conference room at, this was fun, jury duty. Great thing, no one could tell the difference. Vox Pro makes it totally easy. Telling you, if you're looking for the best on-air partner, call my friends at Wheatstone, ask them about Vox Pro, and you will be glad you did.
And actually, the place to get Vox Pro is from Broadcasters General Store. They are a dealer for it, and they have sharp pencils at BGS. Go to the website, bgs.cc, or call them. They love to do phones at 352-622-7700. I've been calling BGS for years, even starting building radio stations with the late Sam Phillips in Memphis, Tennessee. I'd call BGS and talk to those, as Sam would always say, call them pretty girls at BGS and tell them to sharpen up their pencils. So we did. Thanks a lot, Broadcaster General Store, for sponsoring This Week in Radio Tech. All right, we've just got a couple remaining minutes with Jim Tyner, the CEO of Tower Elevator Systems. I should have asked Jim to think of an elevator joke, something about, the business has its ups and downs, but that'd just be too predictable. Right. Jim, what would you like to... Okay, go ahead. It's all yours.
Yeah, I think it's pretty important. If any of the engineers get a chance to ride an elevator, it's very tempting. It's an amazing experience to go up a 2,000-foot tower. It's like being in an airplane. And like I say, it's very tempting, but there is an element of caution that you should exercise, and I'd strongly advise you to understand that they're not foolproof. It's easy to go hop in an elevator maybe and go for a ride and have it stop, and now what? You must be prepared to climb down if you go for an elevator ride on a TV tower. Just don't do it unless you've had some training. You never go alone. No one ever should go up a tower alone. You have the proper protective equipment, and you're prepared to climb down. It can be quite strenuous. It's not for everybody. So So I just advise you to take the opportunity to ride if you can, but only if you're prepared.
That is great advice. In fact, in our prep show, you mentioned this to me, that these are not for fun. These are not just for sightseeing. These are for work. And if you're to ride one, be ready to work if you have to, because you may have to.
Gonna climb down. Mm-hmm.
Yeah. Jim Tyner, it's been a pleasure, man. It's so great to meet you and hear about your innovations and your inventiveness and your family history in the tower business. So thank you so much for joining me and Chris today.
Thank you, Kirk, and thank you, Chris, and Suncast. Thank you, guys. It was interesting.
Indeed.
I enjoyed it.
And I thank Suncast for producing today's show and Chris Tarr for being here. And we're going to have, of course, another show next week. So we'll see you next week. Be sure you hit like and subscribe if you're watching this on whether it's Facebook or YouTube or wherever you're downloading this from or watching it from. We really appreciate the likes and the subscribes. And if you can, get it automatically into your whatever you download podcasts with, that would be great as well. We really appreciate you. And that's it for us. We'll see you next week on This Week in Radio Tech. Bye-bye.